Welcome back developers to Pykidz, a kid developer initiative. Last session we covered the following: why programming is an essential skill, Python is your powerful friend, Python installation and Python versions, Python shell or the Python REPL, operators and variables. Hope you have completed the Python setup and were able to follow those concepts. Today we will be building on top of them. So if you have not seen the previous session, please watch it before you see this. Let us get started with today's session. Data types. We cover data types today. We have seen variables and they store data. This data has a type. Let us open the Python shell and see some examples. Okay. Now I am in the Python shell. So this is a variable and I am assigning some values. And s is another variable and I am assigning a different kind of value. Now based on the type of data, we can do certain specific things on that type of data, or it can do certain specific things. One thing to remember, it is not really the variable that has the type. It is actually the value or the literal which has the type. Variables get the type from the value they are labeling. So for all practical purposes, we can think that variables have a type even though it's not strictly correct. How can you find the type of a variable? Type of x and then type of s. Here you see this thing type. What is this? It is one of the functions directly provided by Python, just like the print function we have seen earlier. These functions are called built-in functions. Now here we are talking about using type to find out if there are, what is the variable's type. So the first case, it's an integer int. The second case, it's string, it's a textual type. We will cover this right now. We are going to cover some basic data types in Python. There are numeric data types. They are integer, float and complex. We will get into more details of integer and float types, but I will not cover complex since in my opinion it is rarely used. There is a text related data type called strings. We will cover this in detail. And last but not the least, Boolean, which is about true and false. We will cover this in brief as well. Numeric types. Let us first talk about numeric types. The first one is integers. Let us move to the REPL or the shell. Okay, we are on the shell now. We already saw type of x. It shows the class, which is another name for type, and in this case it's int. It's a short for integer. So Python supports the integer or int data type. Let us see some examples. So this is an integer, obviously you know this. So you have small, slightly bigger. We can create very big integers values also. Python language does not put any restrictions on this, but the computer on which you are working might not be able to handle very big numbers. For most of what we do, this shouldn't be a problem. So let us just put a huge number and see. X equal to okay, let's see what's the type of x. Integer. That's pretty cool. I think that's a pretty big number, but it's not readable, is it? Even this is not easy to read. Let us see this. Now, is this a crore or a million or 10 crores? Difficult to tell, is it not? But with your version of Python, you should be able to do this. Now, if you actually see, it is actually the same value, but this makes it much more readable. Here, we are using an underscore to separate some of the digits. The value is still the same, but it just makes it easier to read and write big numbers. Support for this way of writing a numeric was added in one of the recent versions of Python. With this data type, you already know that you can do calculations or arithmetic operations. We have seen this in the last session. Let's quickly look at a few of these operations. X equal to y equal to 2. Now I can do x plus y, that's x into y, or x asterisk y, x minus y, and x divided by y. Cool, that works. The last example leads us nicely into the second numeric data type, which we will cover. This is the float data type. The data type is used for supporting numbers which have decimal values. Let us take some examples. We just did a division. Let us look at the type of the result. See, we divided two integers, but the result is a float. Let us just define our own numbers and check its type. X is equal to 0, 2, type of x is a float. You can also have this underscore style which you saw earlier. Underscore is nothing but this character. Now if I type in x, this is the value. Let us see a slightly long number. X is equal to 0.000000008 decimal numbers, right? Now let us see what is its value. What happened here? What does this mean? What does 8e minus 09 mean? It means 8 into 10 to the power of minus 9, which is the value of x, which you already saw. See? So what you saw was a short representation of this value. If you really want to see a full value printed, we can use the format built-in function. I will use the format function here, but I will not cover any details since it will take us away from the topic we are discussing. So the format x, which is our value, this is an expression, a format expression which we have to provide, and you see this is the actual value. It is converting into a string as well. We will see this more. So let us do some operations. X is equal to 10.5, y equal to 2.2, x plus y. So the same operations which we did with integers, you can do with floats too. All of that works. One thing to remember with doing arithmetic operations with floats is that the resulting values of the operations cannot be relied on to be completely accurate. It is generally rounded off to an approximately close number in many cases. This is not because of Python, but because of how floating point numbers work in our computers. Hence, this applies to many languages including Ruby. For our sessions, we will use floats for working with decimal numbers. But when you grow to build a full-fledged application which carries out business calculations, you should use a more advanced data type called decimal. I will not discuss it here, but we might cover it in future sessions. Okay, before we close with numerics, I want to reiterate one concept again. The data type is for the value, and since a variable is assigned a value, the variable ends up having a type. If you change the value assigned to a variable, then type of the variable also changes. Let us take a look at this. S is equal to 1, 2, 3, 1, 2, 3. Now type of S, what did you expect? Obviously an integer. Now if I reassign S to something else, now if I look at the type of S, it's a string, it's a different type. Time for a break now, and please do take a break. Pause this session, move away from your seat and come back after a 5-minute break, and let us start the next topic. Okay, now that you are back from the break, let us cover the next data type, strings. Strings represent the textual data type. It is represented as a class str in Python. We have seen this in the shell. A string is a sequence of characters or a string of characters, and hence the name. Just like integers, we can have very big strings with Python as long as your computer can manage them. Python does not have any problem, and also you won't have many problems with long strings during your course of learning. Let us move to the REPL. A string is created, or to use the developer language, defined by writing a set of characters within a pair of quotes. To be completely on the developer lingo, a string is defined by writing a sequence of characters delimited by quotes. Delimited by quotes means the boundaries, the start and the end of the values are marked by quotes. Let us try an example. S equal to Tenali is a good person. Our favorite Tenali is back. Now we can see the type is a string, and if I just type in S, I get back the value. That is a simple string. This is also called a string literal. Note how the shell or REPL shows this value. It is showing it with quotes. If I print this value, let us see what happens. See, now you do not have quotes shown. This is the actual value of the string. When you type the variable directly in the shell or REPL, it shows it with a quote to denote that it is a string type. For this session, I will keep using the function print for strings so that I don't confuse you on what the real value of string that you are working with. Let us define some more strings. S2 Tenali lives happily in his town. Now here I have used double quotes. Earlier I used a single quote. Now I have used double quote to delimit strings. The type of this is again obviously a string, and when you print it, you will see the value without any quotes. So you can either use single quote to delimit strings or a double quote. Let us try writing another string. Print Tenali likes to eat brinjals. Oh, what happened here? I used a double quote in the beginning and I ended it with a single quote, and it is saying that I am not able to find the end of line while scanning string literal. So it is complaining that you did not complete the literal and you have closed it. So because if you start with a single quote, you have to end it with a single quote too. Similarly, if you start with a double quote, you have to end it with a double quote. If you do this where I'm starting with a single quote and ending with a double quote, you will see the same problem. So always ensure that whatever you are starting with or the delimiters are uniform. Either you use single quotes always or double quotes always. Let us look at a few more examples of different scenarios. Let us take a string with apostrophe in it. Tenali's life is good. This, obviously, we have a syntax error here. Why? Because since my string has a quote in it and I use in the string definition, I started with a single quote. The apostrophe, which is another single quote, it looks like Python thought that you have completed the string at this point, but you have not. So what do we do? You can use arrays and I can use, instead of single quotes, I can use double quotes as the boundaries of the string, and that works. Now let us look at trying to have write a dialog. Print. So a dialog generally will have quotes in it. Tenali's life is good, said the king. Obviously, it does not work. This invalid syntax error comes again. In this case, we have all sort of quotes present, and this confuses Python. How do we get around it? We use the backslash. This is the backslash. Right? This is the backslash. A backslash can be used to tell Python that you should not think this quote as the end of string. You should move on. Or to quote the developer term, you should escape it. So backslashes are used to escape quotes inside your string. Let us see an example. Print. Now I have the quote, right? So I escape it with a backslash. Then I say Tenali. Got my spelling wrong. Again, I'm going to have a quote, so I'm going to put another backslash. Life is good. Again, a backslash quote, said the king. Now, if you see the string with the quotes for the dialog, and the complete string is coming as is. Can make a subtle change here. I might just take out this backslash and see what happens. This also works. Reason being that in our string, the delimiter used is a double quote. So Python will always look for another double quote to complete the string. Tenali's life, this is a single quote, so Python already understands that is not the end of string. So you have to only escape double quotes in this case. This is good, but there is another way I can achieve this, and that way is much more powerful. Let us look at it now. Instead of using a backslash to escape individual quotes, we can use a totally different delimiter. This is called the triple quote. So 3 quotes, right? Triple quote. The specialty of this delimiter is that it is something that does not ordinarily appear in normal sentences. So when you use it, Python does not get confused. Let us take an example. I use print I use the triple quotes and then I just type in my sentence. Good, said the king, and I close this with a triple quote. That works. No need to look for all the quotes inside the string and escape them. Just use the triple quote delimiter and you are done. The triple quote provides you with another powerful capability or feature. Let us try to define a string that goes into multiple lines. We'll use the normal quotes and see how that works. Print Tenali is a good person dot. Now I'm going to just type enter because I want to go to the next line, but Python will not allow it. Python does not, by using normal quotes, Python expects the string to end in the same line. You cannot make the string flow into multiple lines. Let us now try it using our newly learned triple quote delimiter. Print, now I'm going to use triple quotes, Tenali is a good person. Now I'm going to hit enter to go to the next line. Oh, that is good. So are you. I'm going to end now the triple quote and lo behold, that works. So with triple quotes, we can easily create strings with apostrophes and quotes within them. We can even create multi-line strings. I think we are good here. We have spent a lot of time trying to figure out different cases of creating and assigning string literals. I know it has been tedious and long, but I wanted to look at these cases so that you have a sound grounding on string literals. It is something you will use very commonly in your life as a Python developer. Time for another break. Take the 5 minutes, step away, do a backflip if you can without hurting yourself, and come back. You have earned this break. Okay, now you are back from it. Let's move on to string operations. We have been doing a lot of string literal definitions. Let us do some operations on strings. We will cover a few of them here. Let us look at the first one. Print, let's clean this up. Print Python can do, I am using the plus operator, and let us see what happens. You see them join together. Concatenation is nothing but joining two strings together. Let us do that again with our favorite person. Print Tenali goes to the school. So again you see concatenation working. Let us try now something else. Print Tenali to. Now I am using a asterisk or an into. What is Python doing? It is repeating the string multiple times. Remember, in all these cases I am using print function only to show you clearly what the string contains. I can do all these operations and definitions of strings without print too. Let us see one. And I do this, you see, repetition happened as expected. Only thing is that the shell shows it with quote delimiters. If you use print just by using the arrow keys and do this, now you will see it without the quotes. Okay, you just saw plus and asterisk, or a plus and into operators used with strings, but they mean different things to strings when compared to numerics. So don't confuse them. Plus is concatenation in strings, but in numerics it's an addition. Similarly, asterisk is repetition in strings, but for numerics it's multiplication. Also, division or subtraction are not applicable to strings. Only numerics support these operators. Now let us try something completely different. Print here you go per. Isn't that cool? What happened here? This is called method calling. I'll repeat, method calling. It is another way to manipulate or work with data types or just data. We will learn a lot more about this kind of operations later. Now we come to another interesting feature. Let us look at this string. Print you see Tenali's house is far away. Now what I want to do is use the name of the person as a variable. That way I can say that same sentence with different people. Let us try that. I will define a variable Tenali. I am using double quotes here. You can use single quotes, up to you. Okay, I will try to print you see name. I will just put the variable here. House is far away. Of course, that did not work. Python just thinks that name is part of the string. We need to do something called interpolation for this to work. Interpolation. Interpolation is about looking at a string literal, checking if it has got any variable placeholders present in them, and then replace them with variable values in the same place. Let us take an example. I will try to use Python to do this. You see and behold, that happened. In our example, the name variable is placed in the middle of the sentence. When Python sees f in front of the string, it knows that there could be a placeholder variable inside the string. There could be more than one, two. The placeholder variable is placed within braces. Python identifies it and substitutes it with the value of the variable. Now let us change the variable and try again. Name equal to Kali. Now if I just go back and use the same print statement, you see Kali's house is far away. That works again. This is the f-string method of interpolation in Python. There are other methods of interpolation supported by Python, but this is a good and clean one. So we'll just stick with this. There is one more data type that we need to cover. Booleans. This is a separate data type of Python to express the concept of true and false. The only two values of the data type are, as expected, true and false. Let us see some examples. S equal to true. Now if you try to use the type S, it's a bool, which is a short form of Boolean. Similarly, if I say F is equal to false, and when I do a type of F, I get bool. So you see class again, which is another name for type, bool. Though Boolean is a special data type present in Python for expressing the concept of true and false, other types also exhibit this concept of trueness or truthy, or falseness or falsy. The integer 0 is considered as false or falsy, and all other integers are considered to be true or truthy. I will show you this a little later. We will see a lot more about Booleans when we come across conditionals and conditional operators. For now, let us move on. Now, let us mix it up. Let us try mixing different data types and see what happens. Okay, let's mix it up. Name equal to age equal to 12. Now I'm going to do name plus age. Now you know the plus operator is supported by both strings and integers, but Python complains. We know name is a string and age is an integer. A string says that you can use plus to concatenate two strings. An integer says that you can use plus to add two integers. But we are doing something else. We are using the operator with a string and an integer. Python looks at the first value, then looks at the operator and thinks that you want to do concatenation. It then looks at the second value, expecting it to be a string, but it finds a number. And of course, you can't do that in Python. So the error. You try it the other way and you will see an error, but the other way. Let's do. Now it says you cannot add a string to an integer. This happens because Python will strictly follow rules that are applicable to the data type. In developer language, we say this as strongly typed. This means you cannot mix types of objects freely with different operations. This is what you saw with the plus operator here. That said, sometimes you want to change them from one to the other. Let us look at an example. Age equal to 11. Now if I do age plus 10, you will obviously get an error. But we know that the actual value inside the age is an integer. We by mistake store it as a string by putting those delimiters. In such a case, we can tell Python to change it up. I can do int of age plus 10. That worked. Here, by using the built-in function int, we are able to convert a value defined as string into an integer. This is called casting. Here are a few more examples. Age equal to 20. My age is plus age. Obviously that does not work, but I can do this. I can use the built-in function str or string and cast this integer into a string. Let us do a little more. A equals 23. If I do float, which is another built-in function of a, I obviously get a float now. So I can show you that. That's a float. There is another built-in function bool, which as you would expect, see here, because a is 23, which is a non-zero number, when you converted that into a Boolean, it became true. I had mentioned this earlier. Now if I reassign a is equal to 0 and then cast it with the bool built-in function, you will get false because 0 is falsy. One thing to remember is that casting is not magic. You cannot convert anything to anything. The underlying data must be compatible. Let me show you what I mean. A equal to 23. Now if I convert using casting, using the built-in function int, this works because the underlying data is actually a number. But if I do this, and then I try to cast it, no, that doesn't work. That is textual content, right? That is textual data. So Python cannot magically convert that. It looks at a text and it says that I can't take this text and convert it into an integer. The underlying data must be such that Python can understand it to be of the type you are casting into. Otherwise, Python will spit back an error. Before I close this part, I want to show you another good thing about our f-string based interpolation. Print f-string, right? My age is, I am using the braces. That worked. You can see that f-string interpolation takes care of doing the casting for us. I did say f-strings are cool. Okay, there are other types in Python. One such kind are the composite data types. These types contain collections of other data. There are also custom types, types which you create for your own work. We will cover both these later. For now, we are done with data types in Python. Let us summarize. We looked at data types. They define the type of data and what you can do with them. Within data types, we first looked at numerics, ints and floats. We did some operations with them like we did in the earlier session. Then we looked at strings, defining literals, doing operations on them, interpolating them. We also looked at booleans, the truthy and the falsy. We then looked at how we cannot just mix things up directly because Python is strongly typed. But when you want to mix them up and you know what you are doing, you can use casting. Now we close this with a list of built-in functions we have seen till now in our sessions. Just a way for you to remember them. We are done for today. Hope the concept of data types is clear to you. If you have any questions, please ask them through comments. I will surely try and answer them. Bye for now. See you in the next session.